Welcome to the project demonstration of design and implementation of an ARM-based AA module for ectopic beat classification using custom and structural tuned lightweight convolutional neural network. So here the convolutional neural network along with artificial intelligence to detect the diseases based on the sensors input will achieved by this Raspberry Pi, which is the main processing unit. And to achieve that, the sensors mainly we are using is electrodes, ECG electrodes, which are interfaced to this ADE8232, which is going to provide the ECG signals along with probes detection. So this is the input to the Raspberry Pi through the Arduino Uno board. So we are using the Arduino Uno to convert the analog to serial, means whatever the analog data is coming from this ECG ADI232 board is the analog voltage, as a Raspberry Pi doesn't consist of inbuilt A to D converters. That's why we are using this Arduino Uno board to convert the analog data to serial, and that is input to our Raspberry Pi directly through the serial communication. And we have interfaced the MAX30100 heart rate sensor and thermistor temperature sensor and MEMS ADXL345 to detect the fall detection. This is the fall detection purpose, and heart rate and SpO2 getting from this MAX30100 and thermistor temperature. So totally we are getting the 4 health parameters including the ECG and fall detection. So these sensors continuously monitored by a Raspberry Pi 02W, and here we have inserted the memory card, which is of 32 GB Ultra Class 10 memory card. Before inserting that, the steps is initially we need to load Raspbian OS into that, and after loading the OS we'll insert that memory card here and connect the HDMI port and on the power supply. There we can see our on screen the operating system. Once we get the operating system, then inbuilt it will come with the Python. Then later we need to install the Python packages which are related to our scikit for the machine learning along with the AI for CNN and sklearn. So these are the main things we need to install, and then after we are going to write the Python code to read the input from this or Arduino Uno in serial communication along with sensors data. So it will keep on process. This one is the basic level. Then coming to the artificial intelligence, this is the data directly getting from this one will be stored in a text file, that is nothing but a JSON format, and then our machine learning algorithm will extract these ECG values. As we know that ECG nothing but PQRS signals according to our base paper. So these are the PQRS signals which we are going to get along with the values. So here showing the 0 and 1, but not like that. It's going to the 0 to 255. 0 to 255 the variable voltage values will be getting input to the Raspberry Pi in terms of serial values. So based on the time gap between the PQRST signals, so these are the PQRST signals, and based on the value and time gap we are going to differentiate and estimate the disease of the particular person based on this ECG signal, means nothing but the PQRST signals amplitude and time gap between the PQRST and each P and P and between the PQRST. So this is the main inputs, and it will estimate same with our heart rate and SpO2 along with the temperature. So these two sensors along with the ECG to detect and classify the diseases, and the diseased person disease will be displayed on the 16:2 LCD screen. This is for the disease classification using the CNN. And the next is extra is fall detection. Now the abnormality detected, the same data is uploaded to the ThinkSpeak. So these are the previously captured values while we're testing the project. The field 1 is the fall detection, heart rate and SpO2. So the SpO2 values and temperature values along with ECG values. So these are the values we are going to continuously receive them. Okay, and here we can erase this old data to get the fresh data, to plot the fresh data. So you can download them. For that, data import export, and go with the download option and download that, and the data will be opened in Excel sheet. So that will consist of date and time along with the number of samples till now collected. So this one is the date and time at which the samples got collected, and the second one is the entry ID. That's the entry ID, nothing but how many samples till now collected, 86 samples. And field 1, as we discussed from this chart, The field 1 is the field 1 is fault detection of the 0 or 1, heart rate, and SpO2. Temperature is a field 4, field 5 is the ECG. So these are the values we have captured over here. So till the field 5. So after we took the backup, now go to channel settings. So data import export to download the data, and channel settings to clear the channel. In that, only do clear the channel, don't delete the channel, only do clear the channel. Unsuccessfully channel got cleared. Now go to private view. There we can get the no data was present as the previous data got erased. So after this successfully cleared, now the first step is we need to enable the hotspot in your phone. So that is the project 2575 without any space, without any capital letter, and password should be 123456789 and AP band should be 2.4 gigahertz. After enabling these hotspots along with data, log into the ThinkSpeak. So this is the second step, and the third step before mounting that is, so place this red and yellow to the right hand side. So you can place at the wrist section and elbow section, and the next before on the kit only. Right, okay, so place them as is shown over here. So after remounting, now we can on the power supply to the kit. This is the main adapter to on the power supply to the kit. On the power supply, so hold this reset switch. This is very important. This is a reset switch of the Arduino. Hold the reset switch till a welcome message displayed on the LCD and the buzzer will be on and off 2 times. Means we need to hold the Arduino to send the data. Means there is a process delay will be there. So if we send the data continuously, initially it will take around 20 to 30 seconds duration to log into the operating system inside our memory card. Now you can see the heart rate, SpO2, temperature 00 as there is no input from the our Arduino Uno board. So we mounted everything properly, and we can see the one device is connected in your mobile phone, that is our Raspberry Pi. Now we can release the reset switch. So if it is showing any place the probes properly, so we need to check with that. Right, just probe got released, so place it properly. So whenever the probes not placed properly, then this kind of message will be displayed on this one. So if you place the finger over here, then the system will keep on calculating our heart rate and SpO2. Right, you can see the heart rate will be calculated slowly. Probes cut but isko probes. Right, so you can see if you're moving there, the right is perfect. So it's normal ECG now. Okay, and if it's any abnormality, like if you made manually any conditions, then the system will provide us detected. Right, so it's bradycardia disease. Okay, so just we are moving that, we're making some abnormal to that one. There you can see heart rate and temperature will be calculated. So if don't move the finger, so we place the index finger over there. Right, so as we move that, and coming to the temperature, so we place the heat object over here. Right, so we are going to provide some heat object to this temperature sensor. So as is normal ECG now. Right, so high temperature message, and coming to the ThinkSpeak, so the data is continuously uploading over here. So you can see that this is a heart rate. When we click out there, we're going to get the data along with the date and time, and temperature has got raised, and ECG values. Okay, so this is continuously uploading the data to the ThinkSpeak. So we're demonstrating with the ECGs. So when the abnormality we have detected, just change the position. So Right. So there we are detecting the arrhythmia detection, and we are just changing the position. Right now it's normal ECG. Right. So in this case, this is the just showing the output stages of normal ECG, and when we place the finger on this one, it's arrhythmia detection. If we moving the hands, the electrode section, then we are going to get the abnormal ECG, like which leads to the detection of a disease. So is the normal section here, ECGs. Okay, and is a temperature sensor, max 32, max 3010 100, and a MEM sensor for detection of the fall detection. Right. So this was the heart rate along with SpO2 values. Right. Right. So coming to the components over here. So as we discussed, this one is the AD8232 ECG module, Arduino Uno board, ADXL345 temperature max 30100, LCD board with driver and Raspberry Pi 0W, and a buzzer board to provide us the audible alert. And this one is the breadboard to distribute the 5 volts power supply throughout the input output modules of our project. Right. Thank you. So once we remove the finger from the sensor, then automatically the details will be goes to the 0. Right. Right. Thank you.